Hello, this is Math with Beth, and we are going to do limits, but limits that are going to infinity. So here is how you can do them. So step one is to take every term in the top and the bottom and divide them all by the highest degree of the bottom, meaning the x's. So doesn't matter what's happening on top. Looking at the bottom, the highest degree is x squared. So I'm going to take every term and divide it by x squared and reduce. So same thing on the bottom. So some of them are going to turn into nice numbers. And for some of them, we're going to have a number over an x. And maybe you've seen this before. If not, I can explain it. But the limit of any number over x as it goes to infinity is 0. The reason why is because you've probably seen a graph of something like this, and that it looks something like this. It has kind of two parts to it. There's an asymptote here and there's an asymptote here. But as you see, if we go to infinity, this part is going to get closer and closer and closer to 0. And remember, the definition of a limit is what are you approaching? So we're definitely approaching 0. And then even if this was going to negative infinity, the same thing's happening this way. We're getting closer and closer to 0. So just a good thing to remember that the limit to infinity or negative infinity of some number over x is going to be 0. So when I start reducing this, I'm going to keep that in mind. So anything over itself is just 1. But this one's going to turn into 4 over x. So I'm just going to consider that 0. This is definitely a number over x or x squared. Same thing. So I'm just going to consider that 0 as well. Here, these are going to wipe out and leave us with 2. This is going to become 1 over x. So I'm just going to consider that 0. And same thing. Okay. So that means, and again, some instructors are going to be very specific about how they want you to write this. So I'm just really trying to explain it, and I'm not being amazing with my notation. So they might want you to write the limit every single time. So basically, the limit of this function becomes, so I guess I can call it f of x, I don't know what it's called, becomes 1/2. So disclaimer, be careful with the notation and listen to your instructor about the notation. I'm just trying to explain how to do it. So divide everything by the highest power in the bottom, reduce, keeping in mind that anytime you end up with more x's on the bottom, it's going to turn into a 0. So let's try that again. So this time the highest power is the x to the third. So I'm going to divide everything by x to the third on the top and the bottom. And I'm going to reduce, keeping in mind that if I end up with more x's on the bottom, I'm just going to consider that a 0. So if at any point you get a little confused, why is this one 0 again? I would just graph whatever it is that you're questioning. And you'll probably see that as we go to infinity, it's going to be approaching 0. So this one's going to turn into, again, I'm not being careful with my notation. So if your instructor says to keep writing the limit, please listen to that part. This would turn into 2. This would be 5 over x. So 0, 4 over x squared, 1 over x squared, 0. This would turn into 3, 6 over x. So 0, 7 over x to the third, 0. So final answer, 2/3. So if you do enough of these, you'll get the hang of it, and you could probably skip this step. But again, only if your instructor is okay with that, because you could just kind of think through. Another way some people teach these, but again, not all instructors like it, is to think of it as being similar to how we did horizontal asymptotes. So remember, for horizontal asymptotes, when you ended up with the same degree on the top and bottom, remember you would just take the coefficients that were in front of it. So I could look at this and in 1 second say it's going to be 1/2 because I think of it like horizontal asymptotes. But your instructors will probably want to see more work than that. So just be careful. All right, let's do one that's going to turn out a little different. Highest power in the bottom is x to the third. So dividing everything by x to the third, and you're going to see that this one's going to turn out a little different. So I want to show you a couple that aren't the exact same as the ones we've been doing. So on top, I get 4 over x, so that's 0. But this ends up as x to the third. So we'll deal with that in a moment because that hasn't happened yet. This we can consider 0, and this we can consider 5. So when you end up with x's, you then actually think about plugging in the infinity or the negative infinity. So if I'm plugging in infinity into x to the third, even if I raise it to the third, that's still going to be an infinity. And on the bottom, I have a -5. So the 5's not that important, but the negative is. So really, this is going to turn into a negative infinity. And again, when you're just starting these, you can always double check. Graph the function and see if that makes sense. See if as you go to the right, because that's what this is really saying, right? The x's are going to infinity, so way to the right. Does it indeed look like the graph goes to negative infinity? So you can always just double check it first by graphing. All right, let's do 2 more just to see some different types of examples. This one, I'm going to be dividing everything by x to the third again. But the only difference, and I think this is even the same problem we just did, the only difference is we're plugging in negative infinity. So I just wanted to show you an example of one that was going to negative infinity. So this is the same one we did, I believe. So that would be 4 over x, so 0. This would be x to the third, so it's still there. This would be 0. This would be -5. Same problem we just did, but I'm plugging in a negative infinity. So negative infinity raised to the third will still be negative, but 0 minus 5 is also negative. So this time it turns the answer into positive infinity. Last one, dividing everything by x to the fourth. Okay, so this turns into 0 minus this turns into 0 minus this turns into 0. On the bottom, I end up with 2 plus 0. Again, I'm doing the 0 so quickly because I'm just quickly seeing if there's more x's on the bottom, I know it's going to turn into 0. So I end up with 0 over 2, which is fine. Zeros on top are fine. So 0 divided by 2 just means the answer is 0, which just means that happens to be what we're approaching. Most likely because there's an asymptote at y equals 0. So that is how you do the limits at infinity or negative infinity. If you have any questions on that, please definitely let me know.